Hey, welcome everyone. Today we're going to be building on our discussion of the role of networks in mediating spread of knowledge, attitudes, beliefs, innovations, information, misinformation, ideology, and pathogen. And in anticipation of tomorrow's lecture on network dynamics, dynamic networks, we're going to be building up a model in short order, which involves network dynamics. And this will involve covering a bunch of different material. So we'll have to go through a variety of steps with this. And we're going to have to move quite quickly. Because we're going to be moving quickly, there's a risk that you'll be thrown off at some point. And I do want to highlight that I've posted to both the LMSs a mobility model called Neighborhood Mobility V13. It's under the title Neighborhood Mobility on the Fields LMS. And I would welcome you to refer to that model if you'd like to see a more elaborated but complete version of what we're going to be building. But we will be building a stripped down version of this model, and we'll see how far we can get within the strictures of the hour allotted us. Okay, so to begin, we're going to have our AnyLogics up. And I'll be switching to my to depict my AnyLogic here. And we're going to create a new model. We will do new model, and we will call it Minimalist ABM Neighborhood Neighborhood Mobility. Okay. The model time units will be hours, and we will complete the creation, the initial sort of creation of that model. Okay. Now, this model will involve one active agent, but it will involve a set of others that are playing a supporting and quite passive role. But we're going to create them in a certain order so that they exist in the right order to sort of instantiate the properties of the active agent. So we're going to be creating in succession home agents, workplace agents, and community place agents. And we're going to be defining for each the agent type, and then we're going to be defining populations thereof. Now, we've been around the block a few times now, so I'm going to move quickly, and I hope you can follow me. And again, there's that reference model if you encounter trouble. Okay, so first of all, I'm going to add in 3 parameters. There can be each of type int, and they're going to be count homes. This is going to give the count of homes. I'm going to go up here and I'm going to have a parameter count workplaces. That 2 is going to be an int, and I should assign default values for them, and I will do so in just a minute. And I'm going to have one be count community places. Okay. And then finally, there's going to be count. There's going to be, I'll call it population size. Okay. So I see that Jinho has just joined. So if one of the students locally might be able to, could just let him know, answer any questions from what I've done. Basically, I've created a model, set the time unit to be hours. I've noted our plan to have a communicable mobility model with dynamic networks. We've just gone to main and we've added in 4 parameters. Each of them is of type int. All 4, including population size, needs to be of type int. And their sizes, their default values, if we don't override them, in this case, because they live in main, where we'd specify them as in scenarios, their default values will be for the homes. We will have 50 workplaces. We will have 25 community places. We will also have 50 by default. Again, that's if the scenario doesn't override them. That's what the default means. It's the default value if the thing that creates this, the thing that creates main is this scenario, if it doesn't override it. And population size would be default 250. Okay. So we've just added these. They're all of type int. And again, 50 homes, 25 workplaces, 50 community places, 250 people. Okay, next. Having done that, having set up the model to be parameterized by this, we need to go create agent types for each of these: homes, workplaces, community places, population, so people. And then we need to create populations for each of them. Populations that consist of individuals of that agent type. Okay, so from the palette here, we are going to, from projects, we're going to do new agent type, and we'll do them in that order. And we're doing so advisedly. Home will be the first agent type. How did I do that? I did file, new agent type, home. Okay. Home, as I had stated in my opening few sentences, each of these, except for person, will be a quite passive agent. We're going to go down to the presentation menu here for home. We're going to add in, I'm going to go to the pictures, where we'll have a picture. At least we'll have give it a face upon the world, a picture, a small home. Single family dwelling. Looks like a bungalow. Okay. Okay. So that's home. That'll be our home. Home is where you hang your hat. Okay. Workplaces, or hang your toque. Okay. Workplaces here. We're going to go add an agent type. So home is a singularly simplistic, stylized, one might say impoverished agent type. We're now going to go add another agent type, right click on this, do new agent type, and this will be called workplace. And the workplaces will also give them a rather uniform depiction, which would appear to be a factory. Okay. So that's the theory of workplaces. Give economists headaches. Okay. We're next going to do new agent type, and we'll be adding an agent type here for, I think the next one is community place, right? Community place. And here we'll make it a little retail store. Okay, give it a nice little icon from this. Again, please answer any questions for people joining. That'll be great. Okay, again, we served this model. We added these parameters to main, each of type int, with a default value of 50, 25, 20, and 250. We noted that those will parameterize this model, and what we're going to be doing is adding agent types and populations for each. Populations hold individual agents of the agent types. So we've just gone through and added agent types for a home, for a workplace, for a community, and each of them is recommended merely by a picture. Forgive me for moving fast. It's just we need to move fast to cover this in this single session. We are going to now add in our sort of final agent type, we're going to do new agent type person. And the person is going to be more as befits them. They're going to be more heavily articulated. Okay, so from the pictures palette for person, having created the person agent type, we're going to drag in an anthropomorphic image of our person. And it's going to be there. And we will make its appearance vary dynamically. But for right now, it's a single person at the origin. Hence, its visual position will appear at its logical position. Okay. So that's our person. Okay. So we have agent types for each of these. We have parameters that are going to specify in main. Parameters that are going to specify the size of each of the populations. We've got to now add in the populations. We're going to be doing so in order. The order is important because when we instantiate the properties for people, we're going to be drawing on these, and we need these to be built before. So we had to, we're going to define each of these populations in a certain order that will allow basically the other three to be built before population. So here we go, one at a time. We're going to drag in here home to form I'm going to call it homes. Simply add an S, and it's going to be a population of agents. Make sure you do population of agents. What did we do? We dragged it in, dropped it. I changed its name to homes, and I changed it to be a population of agents. What is the initial number of agents can be? Could anyone tell me? Perhaps a Greek chorus will greet me.
Population size.
Population size. That was a Greek. Oh, wait. It's not population size.
Sorry, no.
Count homes. Okay, it was a Greek chorus, but a misleading Greek chorus. Yeah. Not what they were hoping for the Oracle of Delphi. Okay. We're going to drag in the workplace agent in there to create workplaces, and the Greek chorus in oracular fashion will tell me what's the initial number of agents for workplaces.
Population size.
Workplaces. Okay. Well, they say consistency is a virtue.
Eventually.
Okay. Make sure you answer people's questions because I could see people posting it. Thank you. Oh, that's awesome, Jeff. Okay, what a brilliant idea. All hope is in the young people in this world. Okay. We've so screwed it up. Okay, workplaces. Next, we're going to add in a population of community places. Okay, here we go. Community places. And this is a population of agents. And it's going to be count community places. Okay. Not population size. Okay. Finally, in the moment we've been waiting for which we've been waiting, we're going to drag in person. Okay. And we're going to call that a population of, call it population, just more for to habit. And what's its population size going to be? Population size. Yeah, right. Population size. Okay. 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 We're moving fast and living light of the land. Okay. This is great. This is great. Now, you may want to bring down, if you select these, it shows it as underlined, so you can bring down the label so it's a little bit less confusing. There we go. Okay. Possibly you want to make it neater with these on the left or right side. Anyway, okay, good. Now, right now, this population of people has no options for parameters. Why? Because we don't have any parameters for people. So we're going to go to person, the theory of personhood, the theory of personness in our model. And we're going to give them some characteristics. Remember, agents in models have a, so an agent-based model consists of one or more populations of individuated agents, each of which has a set of characteristics. We'll refer to fixed characteristics. And then a set of states, right? And a set of rules for updating those states, set of actions and rules that govern those actions for updating those states. Here we need characteristics for these people. So for each person, they will have parameters. I'm going to have parameters. Person here as parameter. There's going to be a parameter that's going to be their home. There will be a parameter that will be their workplace. There will be and I'm adding these in kind of wanton disregard for their types because I'm adding them at once. I'm teaching you bad habits and my conscience troubles me. So I'm going to go back to home and I'm going to, for each of them, I'm going to give it a type while we're adding them. I stand corrected, or rather I sit corrected. So here for home, its type will be home. It should be in your list because it's an agent type that you've added in the model, home. It's going to be a reference to a home. It's going to refer, each person will have some information that will refer to say, that's my home, that's my home. Okay. Workplace, similarly, what's its type going to be? Workplace, thank you. Okay. They will not pick any community place. They're not bound to any community place. Community places will be dynamically visited. They're going to, however, have a persistent home and a persistent workplace. Are we okay with this? Okay, hearing no objections. Okay, now let's go back. Since we've added these parameters, you notice I haven't given them a default value. I could have given them a default value of null, which is kind of slim pickings. It's going to be null if you don't give them a default value anyway. But really, that's just if we don't assign them, and we're going to be serious and assign them. So let's go back to main. Let's go down main, and let's go to population. And now we have choices for these parameters because we have parameters. Before this was empty. We didn't have any options because there were no parameters for agents. Now we're going to have to fill in a formula here for each and every agent in the population. In other words, it's going to be a single formula that will be evaluated and used to determine the value for each and every agent in the population. Are we okay with this? Okay. Hearing no objections, let's do that. Okay. So what we will do is we will assign them for homes, this population people, homes dot, and we're going to start typing and it'll be random. Okay. Homes dot random. We're going to pick a random home for this person. Give them a random home. Now, workplace, we're going to assign them a random workplace. Now, you could be critical of that. And you could say, well, why not give them a workplace close to where they live? And if we had schools, and we'll add schools later if we have time. I doubt we will, just because we have a lot to cover. But if we had schools, we might have kids going to the nearest school, and I'll show you how to do that there. Okay. So we have workplaces. That's the collection of workplaces. That's the population of workplaces. And each person will be assigned. It'll run this for the workplace characteristic, draw a randomly chosen with equal probability workplace out of that. Okay. Are we okay with that? Okay. Okay. So each person, theory, is going to have a workplace and a home. Let's, moreover, give them an initial position. I'm going to give them an initial position as set by their home. We're going to have everyone start at home. Word only so in the world. Okay. So for their X location, we are going to refer to their home. Now, you might be forgiven for thinking, well, I'll just say home, but it doesn't know magically whose home. We have to say self.home. Self is used in very specific circumstances. So I'm going to say my home. Okay. Oh, it says, okay, can't convert. Okay. Yeah. Okay, fine. So from a home, I'm going to get its location. And I think I can do get X to get its X location. So I have to set its X location. I was going to show you a different way to do that. You'll see it later anyway, but this will suffice to give them, and this will let us, remember, run early, run often. And I want to show you a picture here that communicates how these things are working. And so I decided to do this at lib and to just put them in their homes. Okay, so make sure this is self.home.getY. So that's for myself, it's a reference to me, my home, get my home, and then get its X location in space and get its Y location in space. Are we okay with this? Home has been assigned up here, and we could do this. Note, if I had added these in different order, these populations, homes might not have been created yet. It might not have been populated yet. That population might not have existed, and it could have caused grief. Maybe we're reserving the grief till later. Okay. Okay. So here we go. Okay. Well, so people are all in their home, but their homes are in a single, they're stacked up. Yeah. Not very helpful. So what we have to do is we have to set their homes to be distributed visually around the space. Are we ready to do this? Okay. So initial location here. We are going to draw this value. You may remember this. We're going to be repeating this quite a bit, so might as well get used to it. Uniform, we're going to draw uniformly for the location of the home between 0.0 and space width with a D. Yeah. And it's almost the same, mutatis mutandis for Y. What's the difference? It'll be space. Hi, thank you. Hi. Are we okay with that? Again, for anyone joining late, I would note that I had noted in my opening remarks, there are posted models in the Fields LMS and the U of S LMS, which showed this model. It's called like Neighborhood Mobility and Fields LMS, and it's called ABM Network Mobility version 13 or something for the U of S one. Okay, So having done this, we're going to make sure you copy it, and we're going to paste it in also for workplaces, because workplaces have to be uniformly distributed. And so do the community places. And I'll do each here at a time just to not confuse you, but I would probably go copy each of these in turn, for the X, for the Y, but this is just about as good. Okay, we're setting X and Y. So make sure you reach out to your neighbor, make sure they're following. If they have folks online, ask a question anytime, and a phalanx of local students will be ready to answer it. Potentially in a stentorian voice. Okay, and assist base height. Okay. Are we okay with that? Now note the location for the person will be at their home. Okay, where they hang their toothpick. Okay, so we're going to right click on this, and we are going to run it, and here we have a thing of beauty. Logically, and to my unartistic eyes, artistically, visually. Okay. What it lacks in creativity, it makes up for in color. Are we okay? Okay, make sure you help anyone who needs help here. Stay firm. People are in their homes. And we have community places and we have workplaces. We are now going to get to the heart of the matter. We're building a dynamic model, and we need to make it worthy of that name. So we're going to go to person, and we're going to be adding dynamics to person. We're going to add two types of dynamics. We're going to add mobility dynamics, and we're going to add infection dynamics. And the two will interact. Kind of like the distributive law of monoidal categories. Okay, so we're going to go to our palette. And we're going to add in a state chart entry point. This is going to be mobility state chart. And again, we're operating with very limited time, and I have a hard stop. So I'm going to be doing this incrementally. I'm going to add in a state, which is going to be called at home. I'm going to add in another state called in transit to work. And I'm doing this to teach a lesson, and also to give us some strategic flexibility if we wanted to examine the impact of agent speed, for example. And another one at work. And then we're going to put in some transitions. These, remember, a state chart specifies the possible states with respect to particular concern, the actions that can change those states and move one from one to another, and the rules that govern those actions. And we're going to see how each of those plays out. Okay, so we want a transition from at home to in transit to work. For now, we're going to set this as taking advantage of the fact that we made the time unit of the model be hours. We're going to set it to 8 hours. Excuse me, 16 hours. 16 hours. After 16 hours at home, they're going to go to work. Are we okay with that? Okay. Okay. Now this might. Okay. Next, we're going to add in a transition from in transit to work, which is going to be a new type. Oh, I should have given this a name. I have taught again bad habits. So I'm going to go up here. I've left it as transition. That's leaving money on the table. You want your model to be intentional revealing. You want to be clear about what these things are, both for yourself and for others, for stakeholders. So here we're going to have, instead of transition, it's going to be, start commute to work. I thought of naming it commute to work, but the commute to work is like a state you're in for some period of time. You're commuting to work. This is starting commute to work because it's more of an event. It's a thing that transpires instantaneously that you move to the state of in transit to work. Next, in transit to work, I'm going to be arrive at work will be its name and make sure it's shown. Make sure show name is on. Bad practice, bad habit to leave them without a clear name. Now, this transition will be an agent arrival transition. So when the agent arrives at work, they will make that transition. That's a different type than we've used thus far, but it will serve us well in our current enterprise. Okay, and we're going to go back from at work to at home. And we're going to go back in, I'm going to say 8 hours, okay? I'm going to change that start commute to work to be 15 hours just to allow them to go to the community eventually, okay? Are you okay with this? So each day they're going to go to work, arrive at work, they're going to be there for 8 hours, and they're going to go back. So this is very nice. It's a nice little schedule. We've given them some behavior, and we could go run it and see, and they'd be going around in these things. But we have limited time. And really, we're going to focus on mobility and connectivity here. So what I want to do here for this start commute to work is give them some mobility behavior. So for this transition here, for the action, we're going to say move to, and we're going to go to their work and note that they have a workplace. So we're going to move them to their workplace. Are we okay with that? Move them to their workplace. And that will actually send them on a continuous path towards their workplace. If we wanted to move instantaneous to, it would be jump to. They would sort of teleport to their workplace. This actually moves them according to their speed. And we'll come back to that in just a second. According to some fixed velocity, some finite velocity. If you said jump to with a lowercase j, they would actually teleport to that. So they're going to be in transit for some period of time, and when they arrive, they will transition in. Are we okay with that? Okay. And then, does anyone want to guess what will happen here? When they leave, what will happen? They'll move to home. Move to, and you may remember they have a parameter, home. Now, if I want to be really careful and lower risk of understanding later, I could have said this dot move to move me to this dot home, my home. But I'm electing for parsimony in expression. Are we okay with this? Okay, make sure you build early, build often. Are we okay? If anyone has help, just post on the chat, and the phalanx will dispatch help and dispatch the problem. Okay. I'm using that 2 different ways. Okay. It looks like maybe someone posted. So, oh, great. Okay. So here we go. I'm running the model. 6 hours pass. When do we expect them to move? After how many hours? Do you remember? 15 hours. So the witching hour is approaching up. What happened? What happened? Where are they now? The workplace. They went back. Where are they now? If you're watching my screen, they're at their home. Back to the workplace. And if you slow down, if you were to slow down, and I won't do this for interest of time, you could actually see them move, glide over the space between their home and workplace. Somewhat in a somewhat spectral fashion, passing through other houses and workplaces and stuff like that. Okay. Okay. Are we okay with this? Okay. So we have people pulsing back and forth from home to workplace, and they actually are moving there. Now, let's go back to Maine, and let's keep our eye on the ball of the critical path. Okay? Here we go. I'm going to go to population. And you'll notice that there's a dimensions and movements area here for population. I'm going to set this initial speed to be, I'm going to set it to be 0.1 just to make a point, okay? Are we okay? 0.1. So what did I do? I went to population of people. So I'm setting this for people in this population, what their default speed is, declaratively, 0.1. Are we okay with that? Okay. Now we want you to run the same model. And having been 10 before, and now 0.1, we've seen a speed vector of 100. So let's see what happens as the witching hour approaches here, right? Okay, well, now you could actually start to see. I don't know if you could see it there, but we are going to slow. I'm going to slow this down here. Well, maybe not quite that slow. They're going to be at work for 8 hours. They went to work at 15 hours, so they're going to leave at 23 hours into the simulation. They're going to be packing up and going home. Are you ready for this? Okay. The phalanx stands ready. Okay. So here we go. So it's approaching, and we should see them repair to home. And there we go. Repair they do. Mind you, I've slowed it down by a factor of 25 here, but you get the point. They're gliding over the space. Okay, now, even on the ice that afflicts Saskatoon right now in an uncharacteristic way, we've been plagued by high temperatures, meaning it approached freezing, of course, from the bottom. We're going to set it to 1 meter per second instead of 0.1 meter per second. Shuffling on ice is a good idea, and there you can go at sub-meter speeds, but we're going to set them here to be 1 meter per second. Okay. Okay. And if I were careful, I'd say 1.0. Okay. Well, look, we have mobility behavior. We want to now, we have just 20 minutes left, 21. So I want to build up some aspects of infection transmission. I could add going to community places, but I want to get to the heart of the matter, and that includes connections. So we may come back to that. You may be wondering why this side of the state chart is not yet articulated, but let's go add in another state chart from the palette, from the agent palette, and this is going to be, do so. It's going to be infection state chart. Okay. We've been through this before. So again, I'm going to go quite quickly. Drag up the state, make sure it turns green here, between this and the state, right? Make sure the state is susceptible. Give it a nice capital letter. Make sure down here you set a state to infection, or infective, excuse me. And next it should be recovered. Okay. We've got to connect those two. And we're going to connect these two. And then we're going to allow them to wane it in their immunity by connecting it back here. We're going to double click on this and move and bend it to our will, just like that. Oh, okay. 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 Something along those lines. Now, right now, I haven't futzed with the rules that govern these, hence they're all right now timeout-based transitions. I want to make sure the basic circulation is going. First of all, build, make sure it's a happy camper. Okay. Now, we do want to change their color. And you may recall the basic rigmarole for this. We're going to go in person. We're going to add in a variable, and it's going to be called their color with appropriate Queen's English or King's English. And we're going to set it to be of type color, spelt according to the dictates of the American Imperium. And their initial color is going to be black. Maybe because it was set by the American Imperium, it should be orange. Okay. Okay. I just got to do it. Orange. You got to protest when you can. Okay. So their color will be orange, but we Canadians will soon make short shrift of that. Okay. So for this acceptable, we will assign color to be lime green. The green shift will wipe out the orange menace. Okay. So color equals lime. Okay, make sure this is semicolon because you're telling it do this, make this. Okay, it's saying color can't be, oh, yes, because it has to be spelled with the appropriate spelling. Okay, there we go. Color equals lime. Make sure this one is color equals red, semicolon. Make sure people online are following. I think there's some good posting, which is awesome. Color equals gray with an A. Okay. What did I do? I added color. I made it a type color. I made its original color orange. I made an entry action, color equals lime, color equals red, color equals gray for this one, so that their appropriate color will change. Now I'm gonna change actually the color visually here for the state chart to denote this. I'm gonna make this one lime for the Royal Navy. I'm gonna make this one red, and I'm gonna make this one gray. And I have trouble. There's gray. Okay. Are we okay with that? This changing the visual color of the state chart doesn't directly change anything programmatically. It doesn't change the governing process. It doesn't change the logic of the model. But what it does do is give you a reference. So when you see green as it's running, you're more likely to connect it with this state, visually, et cetera. It reminds you of the color coding. Okay. But we haven't yet changed the actual appearance of the icon. So we have to go to this icon here. And we have to change that icon. And the easiest way to do it is to go over to person, presentation, this little person icon, shape body. And we need to, for its appearance, set the fill color to color. Okay. Variable color, which we've been setting at each of these places. So as it changes that, this is declaratively characterizing the color of this icon will follow the color of this variable, and it will realize that. Are we okay with that? Make sure your model builds. If it doesn't, reach out for help. on the chat. Okay. We have 15 minutes left and time is closing. Okay. We're running it. And now we see people changing in rather quick succession. They're still at home, but they're at workplaces, but they're all changing in unison. Why are they changing in unison? Who could tell me?
Change how they move through the susceptibility.
That's right. We haven't changed how they move here. This is all by time. And in fact, in 1 hour after coming in here, they go to here. 1 hour later, they go to this. 1 hour later, they go back. Okay, so now let's put in the logic. Now we're getting to the heart of the matter with infection. Okay, so we're going to set things here, and I just, because I neglected it the last time we were together, I need to do it here in main. If you go up to main, we're going to be setting a parameter that applies to people, but we're going to set it for all people together. It's going to be uniform across people. So the place to put that is in main. It's going to be an assumption for the model as a whole. Hence, it's going to live in main. We go to the palette. We go to the agent palette. We drag in a parameter, and it's going to be called mean recovery time, and it's going to be a double. And by default, it will be 3.0 times day. Was it days? Day, I think. Times day. 3 days. That's what this means. 3 days. It's going to turn that into, do the appropriate unit conversions. I mean, this encodes the appropriate unit conversions to convert it to the time unit of the model, which is hours. So this could be 3 days worth of hours. Okay, mean recovery time. And next, we're going to have mean immunity duration. And this is going to be a double as well. And we're going to set this to, I'll set it to 1 month, just to give, thinking of bacterial infections which lack longstanding immunity. Okay, 1 month. Again, it will do the appropriate hour. A month will return the number of hours. Okay. So let's get back to person. We have 12 minutes remaining. Let's get back to person. Okay. So first of all, we're going to set infective. Oh, this should be called recovery. Should have a name associated with it. We could have called it natural recovery. It would be a rate given by 1.0 divided by main dot mean recovery time. The mean recovery time is encoded in main. That's where the parameter, this parameter lives that we just created. 1.0, because that if you have a memoryless process, which this characterizes when this is a fixed rate, if you have a mean dwell time, a mean time in this state of mean recovery time, mean residence time of mean recovery time, the rate of leaving is 1.0 over that. Or to put it this way, with this rate of leaving, your average time in that state will be this. It's a mathematical relationship involving memoryless transitions, Poisson processes, where chance of leaving is same. Okay, similarly with this. Rate transition, give it a name worthy of it. Waning immunity of immunity. Make sure it's nicely placed. Yeah, and its rate. What's its rate going to be? Speak on, stalwart. 1 over mean immunity duration. Hey, mean immunity duration. Autocomplete is sometimes a fickle friend. Okay, I said mean. I said mean. Okay. Okay. That's why it was not being fickle. I was being fickle in my typing. Okay. 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 Now we could run this model, but it would be full of sound and fury. It wouldn't signify anything because we don't have the core logic set up here. So what type of transition is this going to be? It's going to be an infection transition. And what sort of rule will govern it? How do we indicate contact in most network-based models, in agent-based models with networks?
Message.
Message. We're going to have a message. That's right. Message. Okay. That's right. Here, proximity. And we need to also set up the other side of that. It takes two to tango. Someone to get infected, it takes someone to infect them, right? So the infection needs to have a message. There needs to be a recurrent process while someone's infected of exposure. And we need a contact rate. And I stand corrected here. I should have added a contact rate. Okay, so I should have said contact rate. Contact rate. Here we go. Okay, and the contact rate here will be, pardon me, 1.0 per hour. Excuse me. Yes. So I should say like contact rate. I could have said contact rate per hour. It's the default unit. So I guess I won't say it. Maybe I'll say hourly contact rate per hour. 1. You just may not be used to thinking about it. So I call it hourly contact rate. And this will go off at main dot hourly, whatever we call that, hourly contact rate. What's it going to do? It's going to send a message. Okay. Send to random connected. The message will be infected, exclamation point. Now, I feel bad teaching you bad habits. Using strings as messages is unreliable and you can mistype them. And if you check, is it exactly the string? You might forget to capitalize it properly. And it's better to use a thing that enforces a set of choices. And if we had an extra 15 minutes, I would do that right away. But we don't. And so I'm going to have to leave that to a later model. So I'm sending to a random connected. Okay. Okay. So if we run this model, I ran it without knowing I was running it. Let me stop that. What will happen as it is? What will happen as it is? Yeah.
Onto the message.
Because we haven't said it. Well, it's here. It's unconditional.
Yeah.
But there's no person initially infected, right? It's a chicken and egg. There needs to be someone initially infected. Okay. Are we ready with this? And so that's one problem. What's the other problem? Where are the networks? There's no networks right now. No one's connected. Okay. We have 5 minutes. Are you ready? Okay. Okay. Let's. Okay. So we're going to add something we used a couple of times ago. It's going to be connect to nearby people. Are we okay with that? Hearing no objections. It's a function. What did I do? I added a function from this agent. Connect to nearby people. All it does is perform an action. It returns nothing. What does it do? Well, it's in person. I added it to person. Okay. Here we go. Okay, so I would like to be able to refer to something, but I'm not able to. So I'm going to ad lib this as well. So this is going to be agents in range. Agents in range. And my recollection is we have to specify a certain distance, okay? I'm going to specify a distance of 1.0 because it turns out all agents are going to be located right nearby. But that's going to give us the agents, right? And then I'm going to do I think it's for each. For each such agent, I'm going to call it P for person. I am going to say, I'm going to connect to them. Connect to P. I'm going to connect to that person. The old horse knows the way. Okay. Okay. So maybe someone could put it in the chat. Yeah. Okay. So this is great. Now we're going to have people connected, but we still need one person initially infected, don't we? So I'm going to go up to main, and I'm going to infect someone. Now, I could put a certain fraction of people infected. If we had a little branch, we could have a certain fraction, start infective. That's another way to do it. Here, we'll send an initial infection message. Time is short. 3 minutes remain and counting. Okay. Initial, we added a event from the agent palette. It's going to be called initial infection event. It's going to occur once at a certain time of 0 hours. It's going to occur at the 0 hour. Okay, are we ready? Okay, so we're going to do. Okay, I'll do. No. It's okay, fine. You want to do it that way? Okay, fine. Population dot random. That's going to get me a random person from the population. I'm going to send, and I'm going to send a message to a random person. It has to be send a message to a certain agent in that order, message agent. Okay, so the message will be infected. Is that how I typed it before? Infected. And it will go to this random agent. I put an exclamation mark before, I think. Yeah. Okay. Here we go. Infected. And I build it. So I'm sending, what's happening? This thing's going off in main at the start of the model. It's sending a message to a randomly selected person in the population. Are we okay with that? Okay. We have 1 minute remaining and counting. Okay, so here we go. Soon we'll have to put down our pens. Okay, so let's see. Alas, do you see anyone infected so far? I don't see anyone infected. It despite my fervent hopes. Yes.
We did call the function.
Oh, sorry.
Yeah, the function is created but not called.
Oh, we didn't call the function. Oh gosh. Okay. So all hope is in the young people. Okay, this is great. Okay, so what we need to do when we get to home and when we need to get to work, we need to call the. So for entry action here, we're going to call the function connect. So the entry action to this. In fact, I'm going to do it in this mobility state chart coming into it. Connect to and it's going to be nearby people. That's the function I created, like this. Okay. Are we okay with this? Okay. And now, similarly here, when they get to work, we're going to connect to nearby people. Are we okay with that? We okay? Okay. I still don't know that that's going to explain this, but I have tricks up my sleeve to diagnose it if it doesn't. Okay, so let's see what's going on. I still don't see evidence anyone's being affected. Okay, so let's go see what's going on. I'm going to show you a trick. I'm gonna teach you a trick. Okay, so here we go. And actions for this. I'm going to do a trace ln and say this was infected at time. Yes. Sorry? No, it doesn't need to be a particular message. I just said it unconditional. I probably should check that it's routing it to the right state chart. Communication, yeah, it's routing it to that state chart. Okay, so here we go. I'm going to have it print out when they cross that. Hey, I was infected, and it's going to say more over the time, so I could tell. Hey, was it the initial message, etc. Okay, so here we go. Okay, let's go look at our thing. They were infected. Someone was infected. They were infected, but evidently they haven't infected any further person. Why not? Why not? Okay, so maybe this hourly contact rate is a per hour contact rate, 1 per hour. I would have thought that this would fire. So coming into here, I would have thought that they would fire. So I'm going to say here for the action trace ln, I'm exposing someone. My number of connections is this dot get connections number. Okay. There we go. Maybe someone could type that in to the chat. And this will be trace ln. I'm recovering. I'm trying to figure out, are they recovering before they can expose people? I'm recovering. Or is the matter that they don't have any connections? I'm trying to track down what's the pathway, what's the particular causal pathway by which this is failing. It's not realizing. Okay, here we go. We're running it. I'm recovering. Okay. They did not actually expose anyone here. There must be something off here in the timing of this. Then, okay, I'm going to go and set the mean recovery time. What do we set for mean recovery time? 3 days, right? Okay, what I'm going to do is I'm going to copy this simulation. I'm going to paste it here. Goodness. And I'm going to say slow recovery. And I'm going to set it mean recovery time to be crashed. Okay. Well, it's not something I would want. But I've been dealt this hand before, and this is what you get for using any logic on Linux. Tell this to them. Okay. So back to the salt mines. We're going to be here going to this, and we copied this, and I set it to be slow recovery. Let's go see what the recovery time is. I'm going to set it to be 3,000 days. 3,000. And I gotta tell the student that I'm late. Okay. There we go. Good. Okay. Someone's infected there. You could see it. They were infected. Okay. Now it's starting to spread. There it is. It's spread. And everyone's infected now. So there's something about the relative speed at which this is going and this is going. The hourly contact rate is here. Hourly contact rate is 1 per hour. And you notice it does say 1. Hey, get back here. 1 per hour. The recovery time is 1 over mean recovery. So I'm surprised that it is recovering before an occurrence of this transition. I'm very surprised. Evidently, the transition is firing. So I'm going to make another experiment. I'm just probing my thinking on this, debugging my thinking, like what's going on in this model. I'm going to say fast exposure, so our high contact rate, that would be rate. Come on. Contact rate, I'm going to set it to be 100 per hour. That's rather fast. More than 1 per minute. Okay, and here we go. I'm exposing someone. My number of connections is 2. That also spreads infection. So there's something involving, like, why is it that with an hourly contact, well, I'm going to keep that as the scenario. I'm going to go back to the baseline. This should, by all accounts, be called baseline. I'm going to run that. Maybe I didn't run it long enough. I mean, is it possible that it was starting to spread, but no, see, they're recovering before they're exposing anyone. Okay, so maybe it's just chance they're recovering. I'm going to set it to a random seed. I'm going to let it each time be different. Let's just see, is it conceivable as luck of the draw? It was luck of the draw. It was just by chance that person was recovering fast. When I set it to random seed, the infection spreads. And I won't say there's happiness everywhere in the virtual world, but there's happiness in the real world to see the model working. It did die out. It died out in pretty quick order. You could see that everyone's infected here. People are recovering. It's staying circulating endemically. But eventually, by chance, I think it ends up disappearing. But even now, it's got some people infected. It looks like there are some red people. Yeah. Yeah, there's still some. Okay, now it's died out. Okay, well, we built a little mobility model. People connect to others at work or at home. They can spread the infection locally. It's a dynamic network where they are connected to their nearby people at whatever location they may be. And if we had more time, we would add visiting community locations, and we would add interventions which have them work from home or cease going to community places or reduce rates of going to community places. And we could experiment with the impacts of those interventions. But we have before us, dear students, a model that combines mobility with dynamic networks and contagion spread. And tomorrow, we'll talk more about dynamic networks. And perhaps you've seen a glimpse of debugging. Perhaps you've seen a glimpse of me augmenting the model in strategic places to investigate hypotheses about what could have gone wrong. One hypothesis, maybe people are recovering too quick. Another hypothesis, maybe the infection transition isn't even firing, right? Another hypothesis, maybe they're not somehow connected with people. I put in that little message, say, I'm connected with 2 people because I want to see are they connected. Debugging is a matter of building hypotheses, putting in place mechanisms and experiments to investigate those hypotheses. And there too, just as in this sort of modeling, we're thinking about mechanisms by which things could be going wrong. Why are we seeing this behavior? What's the underlying dynamics? And we investigate using experiments or scenarios to understand why is it behaving this way, and often with interventions or debugging, how can we fix the problem? How can we lessen the problem? I hope you take that as a lesson home from today. And now I must turn to my beleaguered or forgotten student. Okay, thank you.